I'm going to present our work title as Mining and Unifying Heterogeneous Contrastive Relations for Weakly Supervised Actor-Action Segmentation. This work is jointly done with Tang, Changchang, Ye Zhu, and Yan Yan. So what is video actor-action segmentation? So given us a video sequence, we are trying to perform segmentations on both actors and actions. If we look at the images, so here we can see a baby and two dogs. So an actor is an object that can perform actions. So here, the actor can either be the baby or the dog. So actions, in a sense, that is the actions that the actors is performing. So here, as an example, which is cloning. So cloning is basically the actions for both actors. In this paper, we are talking weakly supervised VAAS, in the sense that only video level label is available. So we can only use video level label to train our model. We propose an approach targeting weakly supervised VAAS. We are mining and unifying heterogeneous contrastive relations among videos and frames. As a motivation, so previous methods, specifically VAAS methods, follow a synthesis and refine scheme, which means they first synthesize a pseudo annotation for the given the video label for the frame, and they trying to train some model or using some algorithm to refine the rough pseudo annotations. These four shots when especially the initial quality of the segmentation is bad. So it cannot refine the bad segmentation to a good one. Unlike existing methods, our method hierarchically mines contrastive relationship to supplement each other to learn a visually plausible segmentation model, in a sense that we don't need to synthesize a pseudo annotation first and then refine it. We directly use the contrastive relations to train our models. In next few slides, we will show how we do that. So first of all, let me introduce the types of contrastive relations. So in our example, we have three different kinds of contrastive relations. The first one is edge-aware contrastive relation. So basically, we are using an edge detector to detect the edge within the frames, and then when we train the model, we are trying to pull the similar pixel representations within the same category together and repel the other ones. And the second one is a cam-aware contrastive relations. So we use the video level label to pre-train a classification model, and then we use a technique called CAM, so short for class activation map, as a pseudo annotation for the object that we are targeting, and then we similarly we are doing the similar thing to attract the pixel representation within the same class or same clusters, and then reply or push away the other representations out of this category. The third one is tag-aware contrastive relations. So since we have a video level label for the videos that we are training on, so we basically transfer the video label into one hot vector, and then we perform also a contrastive learning way to unsupervisedly to learn the representation more robust. So this is our training pipeline. Our model is composed of two stages. The first stage we have to pre-train the classification model, and then we have to use the edge detector to obtain the edge segmentation, and we also have to transform the semantic label into one hot vector. So the stage one is to generate supervisions to train the model in the second stage. So out of stage one, we have these three different kinds of constructive relations. So in stage two, our model is composed of two branches. So one is the actor branch, and the second one is the action branch. We use a so for the actor branch, we are using a 2D CNN. For the action branch, we are using 3D CNN. And then we fuse the image features and the motion features together and input it into a two-layer segmentation head to generate the final segmentations. Note that although we generate the supervision first, but we don't really train a model to refine the initial pseudo annotation recursively. We are just training the model in a way that we can end to end to get the segmentation directly rather than just waiting the algorithm to recursively update the annotations or the initial pseudo annotations. So in the bottom, this shows like the left one is some samples that we drove from the representation space, and then we pseudo color that. We can easily see the objects can be discriminatively identified, which is good for the segmentation purpose. And the right one is that we show different supervisions and our results. So here are some like qualitative results that compares to the baseline that we can achieve more discriminative segmentations. You can see among different categories, and also here is more like results for different categories of different actions and actors. Yes. So as a conclusion, our approach tries to extract richer supervision signals from the raw image, as well as the videos, breaking away from the conventional synthesis and refine pipelines seen in the prior methods. Extensive experiments demonstrate that a proposed method achieved the state of the performance. We do have some like a quantitative result. If you are interested, please refer to our paper. We don't really include it here because of the time limit. But we just need to get to get a sense of how we formulate the idea and what is the qualitative result, which is more appealing. And thank you.